Hey everyone, good day to you all. My name is Carpo, and I'm going to talk about magnetism today. Now, before I made this video, which I didn't intend to make this morning, I briefly considered who would click on a video called "What is Magnetism?" And I figure there are at least two different types of people. A, people who want to know what magnetism is, and B, those who want to poke holes in the fact that I don't know what magnetism is. And what I mean by that is, in the scientific community, there's a lot of hubris and arrogance about understanding how these forces work. And I'm not going to deny that we understand components of how magnetism works. But there are some questions and holes still left in exactly what magnetism is and why polarity exists. Now, am I a scientist or one who studies physics? No. And because of that, most of us are considered just society, and our opinions don't really count. So I do my own research, and this is why I don't specifically talk about these scientific things more often. I'm fascinated with how the world works, how the universe works, the laws and the mechanics, and I just kind of chuckle when quantum physics, for example, pokes, some sort of a flaw in the fabric of, say, our idea of relativity in general, how and why things exist. So I want to make this a relatively short video, and I just wanted to read you a couple of clips screenshots that I took, because I figure that would explain where I'm coming from better than I could. What inspired me to make this video was the fact that I love magnets. I absolutely love playing with them. I'm a kid at heart. I love lasers and magnets and all that fun stuff. Right here I have a container that is full of magnetic sand, or what many people would consider iron filings, but I live in Vancouver, Washington, on the Columbia River, and there's a particular area where there's a high concentration of this, and you can find this in a lot of beach sand too. But what I have on here are just some magnets, and inside here with the sand, when you lift the top up, now I'm going to do a couple close-up videos at the end so you can see where I'm coming from with what I'm making here, but you shake off the excess and here's what you have. You have a grouping of very fine sand particles that actually follow the magnetic field. This is amazing to me. I don't care how much we understand about science, still magnetism is absolutely amazing. You take the magnet away, boink, just drops down into a pile. Whoosh. So, I was a little inspired to make some jewelry based on this, some resin jewelry. And the other night I did an experiment from the last couple nights. This one actually has one of those magnetic fields trapped within it, but you can't see it because it's so dark. And so does this one. And so, last night I made this when my son and I were doing resin. I made this one, which I'll do a close-up view at the end. But you can see the spikes on the top, and you can touch them, you can play with them and push on them. They're solid. I had to pour this resin so slowly, and it had to be so heated up, and then, very carefully added to this, so the magnetic field would be preserved. And I figure I could turn this into some kind of jewelry. You could do it as like night lights, a million different things, but capturing that, and once you remove the magnet, that field is still there. It's representing, and I'm hoping to make those available. I don't want to necessarily ask for just donations on my channel. I was actually wanting to do a kind of a merch setup on my website, but merch that I made, because I'm an artist. I like making stuff, and magnetism is something that fascinates me. So I've always wanted to kind of capture that. Before I forget, I want to read what magnetism is and what we do know about it. And this is on offlivescience.com. Okay, according to the classical theory, magnetic fields are clouds of energy around magnetic particles that pull in or push away other magnetic objects. But in the quantum mechanics view, electrons emit undetectable virtual particles that tell other objects to move away or come closer. Although these two theories help scientists understand how magnets behave in almost every circumstance, two important aspects of magnetism remain unexplained: why magnets always have a north and south pole, and why particles emit magnetic fields in the first place. And they don't understand. It says, we just observed that when you make a charged particle move, it creates a magnetic field and two poles. We just don't really know why. It's just a feature of the universe, and the mathematical explanations are just attempts at getting through the homework assignment of nature and getting answers, Walker said. And this was a guy who asked the same question as I did. This is off Discover. And he said that he wanted to know how magnetism worked. And so he figured it would be a couple hours of research. 71 days later, this is what he posted. At this point, realizing that I must have either slept through or forgotten the high school physics class, this was when he was asked how magnets work. He just figured he'd forgotten. Where it was explained how magnets manage their singular feat of interacting with each other at a distance, I set out on what I assumed would be a minutes-long odyssey to understand the phenomenon. 71 days later, I'm here with astonishing findings. For one thing, as far as I can tell, nobody knows how a magnet can move a piece of metal without touching it. And for another, more astonishing still perhaps, nobody seems to care. And that was the one I found fascinating. Nobody seems to care. This is something I've seen over and over within, it's not necessarily a flaw, it's just an aspect of the scientific community. It's really hard for people to acknowledge when there's an aspect we don't know. The attitude is always, we'll figure it out eventually, and often we do. But magnets are just this universal, it's one of the main aspects. It's thousands of years we've been researching this. It's not new like quantum physics where we're still discovering. It's like, oh, we still don't get this. So, National Geographic thing that I also copied here says, the Earth is a magnet. Scientists do not fully understand why, but they think that the movement of molten metal in the Earth's outer core generates electric currents. The currents create a magnetic field with invisible lines of force flowing between the Earth's magnetic poles. The geomagnetic poles are not the same as the north and south poles. Earth magnetic poles often move due to activity far beneath the Earth's surface. The shifting locations of the geomagnetic poles are recorded in rocks that form molten material called magma wells up through the crust. Okay, in recent years, Earth's upshifting magnetic poles have been picking up pace. Some studies have shown that they're traveling as quickly as 35 miles per year. This can disrupt navigation systems and cause headaches for travelers. Our fascination with magnetism stretches back for thousands of years. Mesoamericans developed an early understanding of the force, and the Greeks were the first to document its wonders. That fascination hasn't dwindled over the years. Our understanding of magnetism has been critical in shaping the world we live today. Without it, we would be lost, literally. So I hope you enjoyed this video. I know I didn't answer any questions about what magnetism necessarily is, and I think that that's because there's not a lot to say about it. There were some other articles explaining, how the poles align and why they think these forces happen, but I think that that's pretty easy research for the average person. I think the only part to me that was kind of amazing is that we don't understand why we have north and south poles at all. There's this idea of a monopole magnet, which apparently, something I recall reading, somebody just thought they discovered a monopole magnet back in the 60s, but then the study's never been repeated, and so on we go. And I'm not dissing science, I'm not dissing discovery. This is what makes us human. We're constantly discovering new things. And through admitting we don't know sometimes, it's, we have to. We have to. There are just certain forces we can't understand and explain. And magnetism is probably just one of many that remain to be found. So, take care. Thanks for watching, and I'll talk to y'all later.